This is Fenrir. The name comes from Norse mythology, the wolf that hunts corruption. We thought that was fitting for a system that hunts malicious governance proposals on Polkadot. What you're looking at on this slide are four numbers that summarize what we built. 174 real Polkadot governance proposals analyzed, 72 flagged as high risk, 53 tests passing with 0 failures, and 3 Polkadot precompiles working in combination. Let me show you how we got there. Polkadot Open Goal participation dropped 64%. That's not a minor dip. That's governance collapsing under its own weight. The reason is right here. At any given moment, there are over 800 active proposals asking the community to vote. No human being can review 800 proposals, so they stop trying. And while voters are fatigued, the treasury, which funds the entire Polkadot ecosystem, has roughly 24 months of runway left. Bad actors know this. Spam proposals and treasury drain attempts are real and they're happening right now. The core problem is simple. There is no on-chain risk signal. When a voter opens a proposal today, they have no idea if the proposer is a first-time wallet created last week requesting 10 times the ecosystem average, or a legitimate builder with a track record. They're flying blind. Fenrir fixes that. Fenrir is a 3-layer on-chain system, and I want to emphasize on-chain. There is no oracle, no off-chain server, no centralized dependency. Everything runs inside the blockchain. Layer 1 is a Solidity contract deployed on Polkadot Hub. This is the orchestrator. It reads live governance data directly via precompile, encodes the proposal's features, and coordinates the whole scoring pipeline. Layer 2 is where the innovation lives. This is a Rust contract compiled to PolkaVM bytecode, running natively inside the EVM context. It's an ML classifier, a trained decision tree that receives 6 proposal features and returns a risk score from 0 to 100. Layer 3 is the off-chain training pipeline. We trained on 174 real Polkadot governance proposals, achieved over 70% precision on the high-risk class, and exported the model weights directly into Rust constants. The model is baked in. The reason this can only exist on Polkadot, I'll come back to that. But the short version is, Ethereum has no governance precompile. Running RustML inference on a pure EVM would cost 10 to 100 times more gas. This architecture is Polkadot native. Let me walk you through exactly what happens when a governance proposal gets scored. Follow the flow left to right. A new OpenGov proposal appears. Fenrir scorer. Sol calls the governance precompile at address x 8 7 and reads the proposal data directly. The proposer address, the requested amount, the submission block, no API call, no external service, raw on-chain data. It also queries the proposer's history, how many proposals they've submitted before, how many were approved, when their first on-chain activity was, all from the same precompile. It encodes those 6 values into a feature vector and makes a cross-contract call to Fenrir inference, the Rust PolkaVM contract. The ML model runs and returns a packed value containing the score and a flag bitmilk. That score gets stored permanently on-chain in a score struct, immutable, publicly readable, verifiable by anyone. And here's the part that makes this ecosystem aware. If the score is 75 or above, high risk, the contract automatically fires an XCM message to the relay chain via the XCM precompile at 0x0803. The ecosystem knows instantly. 3 precompiles working in combination. Governance reads the data. Asset Hub validates the .e amounts. XCM broadcasts the alerts. That combination is exactly what the Track 2 rubric asks for. Let me show you what the model actually looks at. 6 features, each one mapping to a real-world risk signal. Wallet age in blocks. A new wallet requesting large amounts is a classic bad actor pattern. If the wallet is under 50,000 blocks old, that's about 83 days, the new wallet flag fires and adds 25 points to the risk score requested DOT versus the ecosystem average. If someone asks for more than 3 times what proposals typically request, large request fires another 25 points. Prior total proposals. If this address has never submitted anything before, no history fires 20 points. No track record means elevated risk. Approval rate on past proposals. If less than 20% of their historical proposals were approved, low approval fires 15 points. A pattern of bad proposals. Days since their last submission. Burst activity, multiple rapid submissions, often indicates spam or a coordinated drain attempt. Another 15 points, and track ID, which provides contextual weight based on which OpenGov track the proposal is targeting. The score accumulates 0 to 24 is minimal risk, clean proposer, reasonable ask. 25 to 49 is low risk, 50 to 74 is moderate, worth reviewing, and 75 and above is high risk. The system flags it and broadcasts the XCM alert. These thresholds aren't arbitrary. They're derived from the decision tree trained on real historical outcomes. This slide is for the technical judges who want to understand what's actually happening at the VM boundary. On the left is the Solidity contract's execution sequence. Steps 1 through 4 are reads, pulling data from the governance and asset hub precompiles and encoding the feature vector. Step 5 is the key moment. It calls inference.score feature bytes, a cross-contract call from Solidity running in REVM to Rust running in PolkaVM, two different execution environments communicating through Polkadot Hub's unified address space. On the right is the Rust inference function. It's compiled to PolkaVM RISC-V bytecode, deployed as a contract, and callable from Solidity like any other contract. Notice the pattern. The weights are hard-coded constants derived from the trained model. Every arithmetic operation uses saturating math. There are no panics possible in PVM, and the function is fully deterministic. Same inputs, same output, every single time, on any validator in any block, is why it matters for governance. The score for proposal #847 will be identical whether it's computed today or verified 6 months from now or audited by a third party. It's not a black box, it's reproducible math. Steps 7 through 9 on the Solidity side: store, emit, and if necessary broadcast via XCM. That's the full cycle. The XCM integration is the feature that takes Fenrir from a local scoring tool to ecosystem-wide governance intelligence. Here's the flow. A proposal gets scored. If the score hits 75 or above, high risk threshold, the contract doesn't just store the score, it calls the XCM precompile and sends an alert to the relay chain. The payload is simple and verifiable. It encodes the proposal index, the score, and the risk flags. For proposal 847, that's a score of 82 and flags 0x03, new wallet plus large request. Any chain listening to this XCM channel knows immediately. Why does this matter for the rubric? This is 3 precompiles working together in a real use case, not 3 separate demos, but a single transaction that reads from governance, validates via Asset Hub, scores via PVM, and broadcasts via XCM. These are real numbers from real Polkadot governance proposals. Bonsen Hyofpa proposals analyzed, not synthetic test data. Actual governance referenda scraped from Polkadot OpenGov with real proposals, real DOT amounts, real outcomes. 72 of them, 41%, scored as high risk. That's not a bug. That reflects what's actually happening in OpenGov. New wallets, excessive requests, no history. The model is catching real patterns. The risk distribution shows 35% moderate, 15% low, 9% minimal. The scoring isn't just flagging everything as high risk to look impressive, it's producing a real distribution that matches what a human analyst would expect. And the deployed contract is right there. That address is live on Western Asset Hub right now. Judges can call total scored and verify independently. The on-chain proof exists. Quick overview of the full stack for anyone who wants to dig into the code. Smart contract layer, Solidity 0.8.2 with Foundry. 3 test suites, 53 tests, 0 failures. PolkaVM inference. Rust compiled to PolkaVM bytecode. No standard library, no floating point, all saturating arithmetic. Built to spec for the PVM execution environment. And the test suite covers everything. Core scoring paths, XCM integration, security edge cases, subscription logic. 53 tests because we tested what matters, not because we inflated the count. Production proof, not test theater. Some teams in this track optimized for test counts. We optimized for shipping something real. 174 real proposals scored using a trained ML model. 3 Polkadot precompiles working in combination in a single transaction. A Solidity contract calling a Rust classifier via PolkaVM. Deployed, callable, verifiable right now. Fenrir is governance risk intelligence for the Polkadot ecosystem. It's the thing that runs in the background while the community votes and tells them which proposals to actually worry about. The contract address is at the bottom of the screen. If you want to verify anything I've shown, call it. We built it to be verified. I'm showing you the verified test suite. 33 separate tests proving the scoring engine works. Here are 3 key ones. Test scores active proposal. Proposal successfully scored. Stored on-chain in state. Test high-risk inputs produce high score. Risky proposals correctly flagged score 80 plus. Test clean inputs produce low score. Clean proposals score low 25-30. Passing means the contract is production-ready logic. The testnet transaction issues a temporary Paseo RPC rate limiting, a known issue right now. The contract code itself, bulletproof.